So I'm happy to introduce Secretary Vilsack, who will moderate this session. And as you know, there's 3 places you can find everybody's bios. It's in the printed program that you might have at your table. It's in the event app, and it's on the website. So I'm going to hand this off to Secretary Vilsack. No, you're going to, if you'd like. Well, I could. No, I'd like you to. That would be great. Please welcome Secretary Vilsack.
Well, thank you. Thanks very much. I appreciate the opportunity to be here today. And I will tell you that the pace of change in food and energy, agriculture, is incredibly rapid. And so this panel has a very heavy burden to discuss the consequences of all that. Let me briefly, and I mean briefly, introduce each of the 3 panelists. I think their names and their background will be up on the board as well. I'll start with Ramzi Huntley, who is the Vice President of Clean Technology and Innovation Philanthropic Program Officer at IN2 at the National Renewable Energy Lab. That is a mouthful, which you're going to have to explain to all of us what you do. George Hittel is the Director of the Denver Program Development at Colorado State University, and frankly, that title, I've worked with Jocelyn for about 2 years, and that title does not do justice to what she does. She is Jane of all trades, I guess, for CSU. And John Pellegrino is a professor of research and mechanical engineering department at the University of Colorado. So welcome to all. This format's basically going to be divided in essentially three parts. First part, we're going to give each of the panelists an opportunity, starting with Jocelyn, to discuss whatever points they'd like to make over a few minutes. Then I've got a set of questions that I'm going to ask, and then the last section will be an opportunity for the audience to participate with questions. And if we run out of questions, I have quite a few. So looking forward to the conversation. Jocelyn, let's start with you.
Thanks, and actually, I will introduce myself briefly, but then I'm going to start with a video that we recently created that I think gives you a little bit more of a better snapshot of what I'm going to talk about, which is CSU's role at the new National Western Center. So as Secretary Vilsack mentioned, I'm Jocelyn Hittel. I'm Director of Denver Program Development for CSU, which does mean a whole host of things, but what it primarily means is I'm fortunate enough to get to work on our role in the redevelopment of the National Western Stock Show, which some of you who are local may be familiar with and have gone to a number of times. It has been where it is for the last 113 years, so we are a part of an entire reimagining of that space into something new. So I'd like to go ahead and start with that video if I can. I'm going to keep our AV guys on their toes. May not play the whole thing because it's a little bit long.
The Colorado State University campus at the National Western Center will be a collaborative space for discovery, opportunity, and problem solving, where world-renowned researchers work on answers to global challenges, where the next generation discovers and creates cutting-edge technology in food and agriculture, where kids get their hands dirty, literally, where a university convenes diverse minds around the biggest issues of our time, building bridges and leveraging our collective creativity. We know that the challenges of tomorrow cannot be solved by the thinking of today. This idea is at the core of the CSU campus at the National Western Center, a major redevelopment project in North Denver comprised of committed local, national, and global partners. The CSU campus will have 3 buildings focused on food, water, sustainability, and human and animal health. CSU will also provide a platform for others, a place for diverse partners to activate and educate. The campus will be a place where research occurs alongside exploratory learning, bringing youth into contact with scientists and opening their minds to new passions and new career opportunities. A space open to all, where we will ask everyone which big problems they want to work on, which local to global issues they want to solve, and show them how to get started. A front door to the world-class research at CSU, right in the heart of Denver.
All right, I'm going to actually ask to stop it there because it keeps going, but I just wanted to give you a little bit of a snapshot of what it is that we're hoping to do with this opportunity down here in Denver. One of the things you may have noticed from what the video shows you is that it doesn't really look like typical academic buildings, right? What we are thinking about here in Denver is how to really flip the script on what a CSU building and presence might mean. Lots of kids in those images, lots of outreach, lots of education. And the three buildings that you heard mentioned, none of it, you might not have, you might have been kind of surprised that they're not chemistry buildings or ag buildings or biology buildings. They're water buildings, food buildings, and health buildings. So this presence is also fundamentally interdisciplinary and collaborative, which I think fits well with the fact that the symposium this year is a collaborative effort. So I'm going to give you a really quick overview of the presence that we have at the National Western and why it is that it matters when we're talking about the food, energy, water nexus. So just a quick reminder for those of you who are not local where the stock show is. Not only is it really close to downtown Denver, but it's also really at the crossroads of the state, right at I-25 and I-70. Really visible, lots of folks through that space. I won't say anything about this other than to say this is the new site plan. It's about 250 acres. It keeps the facilities that allow us to host the stock show, or allow the stock show to happen in January, but it also has a variety of other facilities, including CSU's new mini campus. It is intended to be a campus that reaches out to the entire world, while also being a campus that focuses on Colorado and particularly on those neighborhoods that are around the National Western, making those connections between the challenges that we face here in Colorado and those that we face around the world. As I mentioned, it's multidisciplinary. It is also collaborative and has been from the very beginning. So 5 founding partners came together in 2013 to decide that we would create a collective vision for what this redevelopment would look like. You see those up there. So it's us in the city and county of Denver, the National Western Stock Show, and 2 museums here in Denver. Since that founding, we've also added Denver Water as a partner, and we have a whole host of other partners that are going to be joining us here in this space. So just a quick snapshot of what it is we'll be doing. Again, 3 buildings: water, animal health, and food and ag. The first, the animal health complex, is really focused on animal health, but also how that connects to human health. What's the translational piece to that? And has a small animal clinic where kids can come and actually watch veterinarians at work, equine-assisted therapy and equine sports medicine. Again, with the notion that it's very outward-facing, that we're hoping to hook kids and families that are there for other events to come in and get excited about careers in STEM and ag they might not have thought about. Second building is really focused primarily on food and agriculture, again with that big outward-facing K-12 piece, but also things like a kitchen where people can learn how to cook, where community members can use that space to build their own new businesses, and where new products can get tested. Again, lots of audience coming through that space. And then lastly, the CSU water building. It's actually physically connected to the food building, so we're really making those food-water connections explicit in this space. It's a collaboration with Denver Water. We're also looking at other collaborative research opportunities. It'll have both sort of general bench lab water space for research, but also larger spaces that can accommodate all kinds of different technologies. And we're really thinking a lot in all of these spaces about what it means to be innovative and what it means to connect the university to corporate and industry partners. So we're thinking a lot about that, how it helps our students get better educated, how it helps us do more relevant research, how it helps corporate partners to advance the challenges that they need to advance, all within this new setting here in Denver. So I'll mention also that while this is a new campus and a new location, and we're really excited about the different opportunities it affords us, it's also a space where we're building on what we're already doing. So as we are thinking about this food, energy, water nexus that you're going to hear more about from other folks up here on the stage, we are building on work that's happening at CSU. The Energy Institute is working with UC Davis, for example, on energy efficiency and food production. We have other faculty who are focused on things like growing biofuels on fallowed land. We have a new program for current PhD students that's focused on training them in the food, energy, water nexus. Our new Irrigation Innovation Center up in Fort Collins is really focused on these issues, as is our ongoing work with the Ogallala Aquifer. So there's a lot of strength already up in Fort Collins in this nexus, and we are really excited about how the National Western can provide a new location and some new facilities and be kind of the front door to a lot of that work. We also have a team that have started to think about what the National Western Center campus can mean from a long-term research perspective. Not only, how does it fit into what they're already doing, but how can we use this big new space, 250 acres that we have access to, as a living laboratory, so we can start to make these connections in research and also in the minds of the public as they come and see us here. We also have this amazing opportunity, speaking of using the site as a living laboratory, to make a really explicit connection between at least water and energy. And that is that we set a goal many years ago to have the campus be a net zero energy facility. So recently, the City and County of Denver has partnered with a new joint venture, EAS, to think about how they can do that. And one of the big ways that they are thinking that they might be able to approach net zero is actually using heat exchange off of 2 giant wastewater pipes that are currently on site. So if you go to the National Western Stock Show, how many of you go? Local folks, okay. How many of you knew the river was there? Oh, okay, this is a better educated group than most, or ones that go out exploring on site at least more. Most people, if they try to go to the river, what you end up hitting is what you see in that bottom picture. It's 2 big wastewater pipes that run along the east side of the South Platte River. So we are going to move those pipes, put them underground, install heat exchange off of them, and that actually gets us a long way toward that net zero energy goal. Really exciting. It's an idea that actually originated from Ken Carlson at CSU and one of his former students, Jim McQuarrie, who is the Chief Innovation Officer at Metro Wastewater. So really excited to have that be part of the solution. And we're also building on some of the programs we have already started as part of this new campus. So the Water in the West Symposium, our first one was last year. Our second one was supposed to be the day of the bomb cyclone. So I hope that you will join us for our rescheduled 2019 Water in the West Symposium. We've just landed on new dates in November, so I hope that you'll come and join us for that. So we're building on things we're already doing. It's not all brand new. It's really a special place, a place that allows us to focus on the nexus between a lot of different subjects, but particularly that food, energy, water nexus that you'll hear more about. Thanks very much.
Jocelyn, thanks very much. Ramzi, you next, or John? All right.
I think like Jocelyn, I'll also use the podium here. And okay, there we go. All right, so real quick, as the secretary said, my name is Ramzi Hundley. I'm with Wells Fargo. I'm part of our sustainability and corporate responsibility team, and in that role, I have responsibility and frankly, the great honor to work on the Innovation Incubator program. And so I want to tell you a little bit about that today, and particularly what our role is in innovation as it relates to the food, energy, water nexus. So has anyone in the room, and I know I have a couple of colleagues from IN2 sitting here, so they don't count, but anyone else in the room ever heard of the Innovation Incubator? Raise your hand. That's at least 6 people. That delights me. If we can get that at a dozen next year, I'll be really thrilled. So the Innovation Incubator, you've just proven, is now the best program you've never heard of. So it is the outgrowth of a relationship that Wells Fargo has had with the National Renewable Energy Laboratory for a number of years. And it kicked off about 5 years ago and is now a $30 million commitment on the part of the Wells Fargo Foundation, working with our friends at the National Renewable Energy Laboratory. And the idea is to help smooth the transition for early stage startups into the commercial sphere, if you will. And the way that they do, or the way that we do that, is to validate their technology and then put that technology into use in a way that an investor sees the promise of the startups coming out of the program. And so we have two main focuses. One is the technology incubator that you see there on the slide, and I'll tell you a little bit more about that, as well as our channel partner program. And the theme here is on collaboration, and so this program is built with collaboration really at the heart of it. And in fact, we have now more than 50 channel partners, including some from the universities represented here, that help us to identify promising companies that would join the incubator. So important to kind of help you understand why it is that we're here talking today. As you can see, we have historically worked on commercial buildings, and in particular energy efficiency for commercial buildings, hence the relationship with the National Renewable Energy Laboratory, or NREL. But what we've done recently is expand into another area, sustainable production through digital agriculture. And so in that area, we're working with the Donald Danforth Plant Science Center in St. Louis, and they're our partner to help validate technologies. You can see the types of technologies we're looking at there in the bullets on the screen. And the important thing here is that what we're doing is marrying world-class expertise like they have with plant science with promising startups and innovators that are working to bring that into the commercial realm and help that technology grow more rapidly than it otherwise would. And just briefly, tell you a little bit about what we've been able to accomplish so far. So the program has been, I think by really any measure, quite successful. So we've now had 25 companies go through the program. We're in the final stages of adding the next cohort focused, as you saw there on the previous slide, in sustainable agriculture. We have 55 channel partners. Like I said, a couple of those here locally. DU, University of Colorado, and Colorado State are all channel partners of ours, as are other institutions around the country, and incubators and accelerators that are helping to spur these startups in the first place. And so we look far and wide to find promising technologies that are working in this space. And then what I would draw your attention to is what's in the lower right there. So basically, for every dollar that Wells Fargo's foundation has put in philanthropically, the companies have gone on to raise nearly $20 of their own in external funding. So what we're proving is that we have a model for how you can take a company, bring them into the process, and then push them out into the commercial realm in a way that really helps accelerate what they're focused on. And so excited to tell you a little bit more about the program here today and talk a little bit more about what that means for agriculture. I think it's a promising new area that we're working in, and I think there's a lot of opportunity to tie that to what you just saw with Jocelyn and the types of innovation that are happening with the National Western Center and really throughout the state here in Colorado. So look forward to further conversation. Thank you.
Ramzi, thanks a lot. John, you're up.
So now, thanks for giving me the opportunity to do something completely different. So being an academic and not at this very high level, I'm kind of always stuck in the weeds. So what I want to do is first motivate this idea. Can I have that first slide, or how do I advance it? Nope, that's the last slide. Okay, so food, energy, water systems. Food, 2% of the world's consumable fossil fuel energy is used to make nitrogen. And in the United States, most of it is made in Houston by the ship channel and is then rail or trucked up to Minnesota, North Dakota, Kansas, Nebraska. So there's a lot of energy in there. 80% of the water, fresh water supplies, used to make food. And we really, I talked to a fellow at Cargill once, and he told me, we're not in the food business, we export water around the world. All the embedded water that's in the foodstuffs. Producing fossil fuels, produce water, the use of fresh water supplies where needed to create the fracking fluids. And water in general is in short supply. Why is water in short supply? All the water we ever are going to have, we have. What has changed is that by our use, changed by essentially population growth, demands in society, we can no longer stand the 100-year time cycle for a drop of water we use to come back to us. through evaporation, going wherever it goes, ultimately coming down as snow to be fresh water. So we can't stand it anymore. So my premise is that the innovations in food, energy, water systems have to do with advances in manufacturing. They're commodities. So basically, the vertical axis says the figure of merit in the microelectronics or the device industries had to do with the more and more speed from the chips, half the cost over time. And on the horizontal axis is time. And so as we made advances in each of those, went from calculators, PCs, laptops, etc., till we got smartphones. The thing is, we knew that we wanted smartphones and smartwatches back in the 1950s. Chester Gould envisioned it with Dick Tracy. But in order for it to be available to us, we need the confluence of manufacturing advances, that vertical axis, but also ancillary things that came in. Cell network bandwidth. They came to us because of software in the cell towers, not putting in new cell towers. Parallel processing that allowed you to do computation on a phone or on a watch without having the CPU on there that actually does the calculations. You have the equivalent of the weather prediction computers doing your data analytics and then sending it back to it. And that also is enabled by the Amazon Web Services or other cloud services that people use. So that's a Moore's Law type of thing in terms of the manufacturing advances as the first thing. In water, the figure of merit in the water world for desalination is the reverse osmosis membrane. And the rate of water production times the purity of the water, the ability to reject salt, divided by constant dollars, has gone through its own Moore's Law type of trope in terms of from the 1980s up to the 2000s, whereas now membrane technology for doing seawater desalination is used even in the Middle East where they have tons of fossil fuel to be able to do distillation in thermal processes. But it still gives them advantages that you don't have because of those manufactured, gone up 100-fold in the course of 20 years. It doesn't keep going on forever. But those advances, when coupled with the advances in IT that I mentioned on the earlier slide, enables building a truck, like in the lower, to your right, lower right of the slide, that actually has a small desalination facility that gets trucked around to agricultural drainage water to prove out technologies. It's integrated with process control, advanced process control, communication strategies that allows it to be operated remotely and also to respond to changes in the water quality. Why is this important? It allows people to go and test before they actually build a fixed resource plant. So they put in the best technology based on these tests to give them good payback on their water systems. Speaking about water, the Department of Energy is in the middle of the responses to this desalination hub call. How many folks here are involved in that? Oh, okay. Well, the Department of Energy is putting $30 million a year for the next 5 years from the Advanced Manufacturing Office, water manufacturing, to instigate advances in water supply to confront the grand challenges. That means reducing the water intensity in industrial processes, being able to harvest impaired water sources, being able to get better water resilience, and supplying for agriculture as well with water fit for use. CSU, School of Mines, CU Boulder, and NREL are represented on all the major teams that are trying to respond to this. So Colorado is going to be positioned very nicely to be able to take advantage of this influx of technical ideas and funding to be able to basically increase our water efficiency, our manufacturing of water, and the technologies that are going to be used to manufacture water. So in the world of food, energy, water systems, one of my colleagues at CU Boulder recently, in collaboration actually with a colleague up at CSU, they've gotten funding to look at more data-driven manufacturing of crops, food crops. So apparently, if you take all of the tactical issues that folks come up with in terms of what's needed for agriculture, one of them is we got no data in real time. We don't have granularity of data to tell me why this part of my field is giving me different yield on the same crop as this part of my field. Why? And you go to the end of the season, you see, oh my gosh, I didn't get the yield there. I got the yield here. Why? What was different? Right? At best, data on the properties of the soil that are important for the crops and their growth may come at best once a year from a core soil samples taken, widely disparaged, sent out for analysis, and then you know what the condition was, at least you worked. But we have the tools, we being the community of experts in farming, et cetera, they have the tools to intercede in real time. Change the application of water, change the application of fertilizer that might be needed, or let it go a little bit dry, change the pH of the soil, whatever it happens to be. They have the ability to intercede, but they don't know to do it. So what Greg and his team have come up with is this idea of using advanced manufacturing to make a confetti-like sensors. Now, these sensors could be made, are going to be made, at least in the initial stages, by 3D printing, using manufacturing advances and materials development. And my sort of cartoon as confetti meant to really depict what they're going to be. They're going to be disposable, biodegradable, inexpensive to make, and they're not smart sensors. They're really stupid sensors, but there's going to be lots of different types of them. You're all going to have a circuit on it by radio frequency capability so that they can be probed whenever you drive by, get the data, the idea of the sensor, what it's signaling, upload it to the cloud, doing artificial intelligence type of computing on all these fuzzy signals that are responding to different aspects of the water content, mineral content, or electrolyte content, the pH, nitrogen composition, and that's what the challenge is, that materials development to be able to put that into it, but that's what they're working on. That will enable more or less real-time data about the condition of growing things so you can optimize the water use, the nutrient use, the soil condition. Okay? What's next? After that, data-driven manufacturing of food. Vertical agriculture gives us the opportunity to decrease that footprint, make the food where people live. This is a hard problem. Google X took it on at their moonshot factory, and they gave up. They couldn't make money on it, at least they perceived they could not make money on it within 5 years, which was the cutoff of their things. So this is obviously something that does require us, if we're going to go from the boutique greens for an artisanal restaurant, such as is being produced in Jackson Hole, Wyoming, in this vertical farm called Vertical Harvest, that, by the way, in 1/10 of an acre, a 4-story building puts out the year-round productivity of 10 acres. So we have a 100-fold productivity improvement. And they're using renewable electrons from the wind farms that Wyoming has put in all along that Mesembo range. So it is that opportunity. So what I'm going to close off is this idea of National Geo this month came out with this idea of smart cities. So the idea of urban agriculture is what's beyond what's the next thing we can do. The next thing we can do is we can do smarter with what we're doing now. But we need to learn a lot more in terms of implementing everything from advanced manufacturing, robots, renewable electrons, power the LED lights, etc., to be able to do this urban agriculture and at the same time potentially be able to rehabilitate in a brownfield sense urban renewal needs. So maybe Pueblo, Colorado, some of the old steel plants are in a retired power plant, coal power plant, he might start a vertical agriculture facility. In any case, on that note, I've finished.
Thanks, John. Just for purposes of time, the clock that we have in front was not triggered, so not quite sure how much time we have left. I've got my iPhone keeping track of the time, so we'll make sure that we don't run over. Let me start, if I can, with you, Ramzi. I'm very interested in your attitude and your view about blockchain and whether or not folks in your world are dealing with blockchain and what you think might be the benefits of that kind of technology in relationship to food and agriculture, efficiency in terms of producing, traceability, things of that nature.
Sure, happy to. So we have not looked at blockchain as one of the innovation technologies yet, but it is certainly in kind of our wheelhouse for consideration. And I think what's really interesting about blockchain, when I think about it from an innovation perspective, is some of what actually John just touched on in his presentation there, and that is the data visibility. And so if you took the idea of blockchain within the food and ag value system writ large, you'd have the sort of traceability that simply just isn't possible with our current methodology. And I think that could be really interesting from the perspective of traceability. I think it's one of the issues that I hear the most about. When I think about the food and ag value chain, and particularly as it relates to food safety and traceability of food, but it becomes very interesting from the perspective of how do you potentially pay a farmer for different attributes. If there were, quote unquote, sustainability benefits that you wanted to incentivize a farmer for, would blockchain be an opportunity to trace that, to validate that, and ultimately to help finance those sorts of benefits for the farmers that are upstream that right now may not be able to monetize some of that benefit.
Great. John, you mentioned data-driven manufacturing and data-driven agriculture. Curious as to your thoughts about who owns the data and what protections are there to make sure that it's used for the proper purpose. I know that farmers, for example, are often concerned about the consolidation or the development of data, their tractors or combines, whatever, for fear that it will be used against them. So you run across that at conversations about that?
That has not come up in any of the conversations I've had. So I think that's something that really is the focus of a regulatory or a policy-driven motivation. So this futuristic perspective, which I kind of presented there, is very much something that will have these kind of pitfalls that you have to sort of think about ahead of time, just like social media has now, it's 2019, started in 2000, so it's now almost 20 years later that we're really starting to confront these issues, right, in terms of our privacy, et cetera. So learning from that, whatever we tend to put in terms of new regulations like Facebook is asking for now from Congress to regulate us. You could learn from that when it comes to this. The other point is that in the medical community, HeLa cells or biologicals, and how that has spurred biomedicine and new kind of treatments, that's confronted the same type of question. Who owns the data? The patient that it was derived from, the medical investigator, or the company that is exploiting it?
Jocelyn, you've laid out generally the challenges and the opportunities for the National Western Center. Do you see the National Western Center having responsibility in this space of policy formulation? And if so, how's that going to work? Who's going to be involved in it? Where will it be housed?
Thanks. So I mentioned that the National Western Center is fundamentally an interdisciplinary effort. So I think there's no way that we can look at the problems that we're talking about and the challenges that we're talking about across those disciplines and not have to tackle some of the policy implications and challenges that go along with those. even if you're talking about sort of the innovation space and new technologies, a lot of times, particularly in food and in water, some of those things aren't legal. And if any of you are familiar with the legal structure around water in Colorado, it's incredibly complicated. Many law careers are made in water law in Colorado, right? So if we're going to think about and tackle the challenges around water, things like how do we actually accomplish the goals that are outlined in the state water plan, we have to address the policy implications of addressing those challenges. So yes, we are, it's a long way to get to yes. We are thinking about policy, and I think it will need to be a collaboration. There are lots of people across the state who have a lot of strength in the policy, in different pieces of the policy. So much like this is a collaboration here today, we anticipate we'll be collaborating with our colleagues at DU and CU and in their law schools, and thinking about how we can all work together to advance the state of the art with that policy piece very much embedded.
Could I add to that?
You bet.
So one of the things that we see with the Innovation Incubators program is we stand, really kind of in between early stage companies and in lots of cases, electric utilities, water utilities, Fortune 100 companies that have very robust procurement systems. For those of you that are familiar with the electric utility industry or our water utilities, they may have a focus on innovation, but it can be quite difficult to actually bring innovative companies on board because of their risk management processes. Totally understandable, right? I mean, we want a constant supply of electricity, we want safe water. But I would say, for those of you in the room that represent that, think about how you can work with Jocelyn, what they're doing in the National Western Center, to try and get closer to those innovators. Because there's a lot of innovators that really have some promising ideas, but yet it's just very difficult for them to move those into the existing processes with the large partners, because those processes are not designed for somebody at an early stage. Just to give an example, a lot of times the insurance requirements that a large organization would have are simply something that a small startup in no way could ever hope to achieve. They're just not in a place where they could procure that much insurance, frankly. So just lots of challenges that a lot of people don't think about from an innovation perspective, but that process really matters for how you engage early stage companies that are working on these issues and frankly might have promising solutions to bring to bear.
Curious to your thoughts, Ramzi or John or Jocelyn, if you want to talk about this. What's the role of AI, you think, in the future, and the Internet of Things, that kind of approach to this? Will we see that being incorporated significantly over the next how many years? And what are the challenges, what are the barriers, what are the concerns that you have about that?
Well, I think that's exactly what I was trying to kind of make the point of, is that it's happening. It's there. There's no way it's not going to happen. And AI is basically just, fitting a lot of data to a complicated arithmetic expression that gives you predictive capability. The thing about the Internet of Things and cloud-based computing and parallel processing is that you can do that really quick. And so it's there. You just have to decide how you're going to use it. And as you mentioned, who's going to own the data?
Yeah, and I think one of the things that I'm quite interested in, particularly within the Food Energy Water Nexus, is how do we integrate data from different streams? So you've got data coming in, I don't know. I mean, it could be data that's on the tractor. It could be data from flow meters in a nearby river, or something related to your irrigation. It could be obviously weather data. All that is highly interesting from the perspective of how you pull them in together. Yet a lot of those systems in no way speak to one another. And so, how do you bring together that integration in such a way that's actually decision-useful data, particularly for a farmer? I mean, if you're on the farm, you need real live data that you can utilize now. And so, trying to figure out how to make 10 different apps work together, that's going to be very difficult in a farm scenario. And so, my challenge to all of you would be figure out the way to make that as easy as possible from the customer experience and thinking very clearly about who your customer is for that.
Yeah, the only thing I'll add is that one of the things that we're hoping that the National Western can do, because you've got, even now during January, there are about 700,000 people who come through that location. So imagine once the redevelopment is done, we're talking about 1 million in January, maybe 2 million over the course of the year. A lot of those folks are families bringing their kids. So we have a real opportunity to start to get the next generation thinking about what the food, energy, water nexus means, and that it does mean AI, and that it does mean satellite technology, and it does mean data interoperability, and it means drones, and whatever you can imagine. We can't even envision what a career in food, energy, water, or the combined food, energy, water space is going to look like by the time these kids are grown up. So I think one of the things we're hoping to do is sort of point them in the right direction. There are ways that you can engage in this space that are unlike the traditional ideas they have of what it means to work in these spaces now.
You know, John Chambers, who ran Cisco Systems, recently decided that, from his viewpoint, that perhaps as many as 40% of the jobs that exist in America today will not exist 20 years from now. And that means 25 million Americans are going to be looking for opportunities. How do we make sure that the transition that's going to take place in this economy is one that not only is fair and equitable, but basically overcomes some of the distrust that we're beginning to see about science generally? How is that being addressed, if any? Is it being addressed at the incubators? Is it being addressed on the university campuses? Are we engaging in a conversation about how we legitimize the science in the minds of ordinary folks so that a lot of these technologies can advance and advance more rapidly?
So I just take my key mostly from a recent book that Tom Friedman put out called Thank You for Being Late. And he spent the last part of that book, fully half of it, is sort of addressing that question. And it wasn't the university providing the education, but it was providing education and retraining on a very accessible basis in real time. That's basically the only way you can actually do that, to handle displaced workers and the change in jobs.
That's a great book. I noticed in the last panel there was a conversation about something outside the box. Friedman's basically saying it's no longer inside the box, outside the box. It's as if no box existed, and that's the attitude. Ramzi, do you confront this at all in terms of the marketability of products and technologies that people may be coming up with, and concerns about how the consuming public may embrace these notions?
Yeah, I guess what I would say is a lot of that, particularly for entrepreneurs and innovators working in the food, energy, water nexus space, that's really at the heart of, well, in a lot of cases, even why they got in the business in the first place, right? But it's at the heart of what they do, I think in a way that's just different than, more abstract technology that perhaps lives in a data center somewhere if you're, not to pick on Facebook or anything, but, if you're in that realm, that versus, this is the food I'm eating, this is the water I'm drinking, I think it just hits home in a way that's very different. And so a lot of those innovators are very, I think, open to sharing that information. They want people, like I said, that's why they're doing this. They want people to know more about that and provide ways to drive that deeper into the system. And then, yes, I think there's a very real appreciation for what's happened of late in the farm economy, and then you marry that against, to your earlier point about the shifts in jobs overall. So how might one bring technology to bear to be supportive of the farm economy as it is today? And then how might you look at a future where you're actually driving technology is actually driving more opportunity in rural economies in a way that's just very different than what the economy has looked like historically.
The most recent edition of Wired magazine has on the front cover CRISPR, which is the genetic next step in the genome process, suggesting that there was some no question it could help increase productivity, but serious question about whether or not it would be accepted by the consuming public. So in this space, and when we talk about this intersection between food, energy, and water, what role will genetics play, do you think? Is it equally as significant as vertical farming? Is it equally significant as drones and sensors being able to understand with precision agriculture? Do any of you see that this is a fairly significant advancement?
I mean, I think if you ask our partners at the Danforth Plant Science Center, they'd say it's one of the most significant advancements. And yeah, your point is spot on. There are real, I think, concerns in the community about the acceptance at the consumer level. If you think about the conversation around genetically modified organisms and how that conversation has played out over time, I think CRISPR can be part of that. But the ability to make very small changes, in very tactical ways, if you will, I think is truly revolutionary. And when you think about the environment that we're in with a changing climate and being able to try and adapt to very specific needs from say plant growth perspective, CRISPR has, I think, some incredible opportunities to help address some of the challenges that we're really beginning to face now, but certainly will be facing in the coming decades.
Jocelyn?
Yeah, I'd say this is linked to your other question about sort of science in general and equitable progress and how we sort of think about getting folks to acceptance. I think I'll just reiterate that it really is about that education, about hooking kids in who might not have thought about this. I think it's really, a lot of it is about starting really, really early with the science education and getting people really comfortable with and conversant in basic science. So to the extent that we can do that, and to the extent that we can also, I think by the time you're in 6th grade, 8th grade, it's too late to take a kid who might not have thought about a career and put them on that path. So as we're looking at diversifying careers and different disciplines, we really have to start early. I think similarly, we have to start early with the basic science, because and expose people to these ideas over and over again and when they're young, so that the only thing that you see that you have maybe heard about when you're thinking about CRISPR or gene modification or those sorts of things, it's not sort of a fluorescent green bunny. It's this is what we've been doing, and this is how it's impacting you, and really what's the science behind it. What should you be worried about? Make sure that people are empowered to make decisions about these processes themselves based on their understanding of the process.
Great. Well, let's open it up to the audience if there are questions. Got a few more minutes left, and yes. I'm not sure if there's a microphone or if we can repeat the question.
I don't see the world's biggest problem to discuss, which is taking carbon out of the atmosphere. Are any of you doing anything in this?
So the question is, let's discuss a significant issue here, which is carbon and taking carbon out of the atmosphere. What kind of innovations are we seeing, if any, in that respect?
I'm not going to say I could address the entirety of that rather weighty topic, but we are thinking about that in a number of ways. So, for instance, the way the farm economy works, you've got to have a very clear financial benefit for a farmer to add something that's perhaps, let's just say, out of the ordinary. And so if there's an opportunity for sequestration, say by cover cropping or conservation tillage, that sort of thing, how can we set up financial mechanisms by which farmers can be compensated for that effort? What's available to them today, what could be available, again, to that earlier question that you had about blockchain, how might we utilize that sort of mechanism to not only measure the benefit, but also how could we compensate a farmer or someone in the ag value chain for something like that. And then the other thing I would say is thinking about the the last question about CRISPR, what are modifications one could make that perhaps would, in addition to providing the food benefit from a crop, or I don't know, it could be in tree growth, but that you could accelerate the carbon sequestration into the soil via that mechanism as well. So, I think if you expand your thinking around or beyond, say, just yield, but what other benefits might one achieve, I think that's potentially out there as well.
I think there are a couple things that I just sort of jump in on this. First of all, the new Farm Bill that was passed creates a new financial incentive for soil conservation that didn't really exist before. It is requiring at least 10% of all the resources available for conservation to be focused on soil health and soil conservation. So I think there is a growing awareness of the need to spend more time thinking about soil health, which in turn I think will result in better sequestration opportunities. I think Ramzi's right. Not only do you have to have market opportunities and financial incentives for the farmer, but you also have to have risk management tools. If you're going to ask a farmer to essentially do a cover crop for which there may be a market or may not be much of a market, incurring that expense with the idea that over time his soil is going to be more productive if he does this, you have to make sure that if it doesn't work out, that you've reduced the risk if the cover crop doesn't pan out, that you've reduced the risk in some way, just as we have crop insurance today for most of the major commodities. So I think there is work being done now to try to figure out how you could create that kind of opportunity. And then I think finally, I think the reality is that consumers are demanding to know more about where and how their food is being grown and raised. And the marketers of food are anxious to take advantage of what has been quote-unquote sustainably produced, however that is defined, as a marketing strategy, as a marketing advantage. And I think that's going to lead more and more to a conversation on the farm as to how can we make sure that people understand what we're doing, that it is in fact sustainable, that there are specific results from it. How do we commoditize that, if you will, creating ecosystem markets? So there's work being done in that space. Obviously, it needs to be accelerated, but I think there at least is a growing recognition at the policy side.
Yeah, and I'll speak for all of CSU for a moment, and just say that yes, there is a lot of work that is happening around this. Specifically around food, energy, and water. Climate change increases risk and variability in all three of those areas. So a lot of people are looking at it from adaptation and mitigation to what I think your question was, which is really around sequestration. A lot of it with soils, a lot of it in other ways. So there are faculty across the university who are looking at these questions with no shortage of urgency. I think the nice thing that we're looking to do here is really sort of then how do you make that scalable? How do you make it profitable so that it's adopted in the private sector and can really make the impact it needs to, as the private sector has to be part of that solution as well.
There's a lot of research also in biochar and the opportunities that can create to do a better job of sequestration and to retain the carbon. So a lot of work in that space.
If I could just add about biochar, the city of Stockton has got something in Denver.
Okay.
Thank you.
Something to look into. Yes. Next question. There are any? So while we're waiting for the next question, what are the most significant innovations you've seen recently that would give us hope that this water utilization, which is going to be a critical issue for the western U.S., as we have, as John indicated, a limited amount of water. What innovations are out there that you think have the greatest promise for either reclaiming, reusing, preserving, conserving water? Is it precision agriculture? Is it some of the desalination innovations? What are you seeing?
Well, so of course, if you can cut down the amount of water you use per se to get the same amount of yields, that's at the demand side, so that's all to the good. On the supply side, myself and the colleagues in a variety of different places are all working on the development of impaired water sources that with the idea, and that's part of the data-driven manufacturing capabilities, water fit for purpose. So the whole milieu of water reuse is essentially, it doesn't have to be perfect. It doesn't have to be perfect for you to be having it come out of your refrigerator and giving it to your guests with ice and a lime in it. It's got to be fit for the purpose there. So you don't have to take it all the way down. You just have to get the right, sodium absorption ratio in terms of the mineral content in it. You have to make sure that there are no leftover pathogens if you're taking it from a municipal water supply or from some other potentially contaminatable source. And it has to be done in an environmentally sustainable fashion. It's going to cost you some energy to do that. But you have to look at it from a systems perspective, which is one of the things that the DOE and its desalination hub is asking for in terms of a plan, is that you got to prove it. You got to work it out and say, hey, this is the scenario. This is going to give you that result.
Other questions? There's a question right in the front here.
What do you think the role is of this desalination plants and grow houses in terms of demand-side management for electrical usage, of sort of dealing with the duck curve by turning the desalination plants on during the brightest part of the day, or those types of things of sort of dealing with excess load?
So the idea of doing of coupling some desalination to the power plants has been tried a number of different ways. The processes of doing desalination basically don't lend themselves very well to stop-starts. I did a bunch of projects in the past life with folks up at a variety of different places, in the oil patch, at EPRI, and DARPA on algae, right? And that was one of the ideas of you can turn it on and off, so you do this indoor thing. It never works out because the embedded environmental impacts from nitrogen. So nitrogen and fertilizer is your big hit in terms of a lot of the agricultural milieu in terms of the energy usage. From the point of view of doing desalination as a way to take the off-peak electrons and store energy that way, now I'd rather do water electrolysis, actually. So we're doing that also, looking at optimizing water electrolysis processes, make hydrogen.
Other questions?
I just had one more industry that I think needs to get into, and that's waste. I have heard people talk about it.
So the question has to do with waste, food waste. I mean, obviously, clearly that, but just waste generally. But can we start with food waste, because that a third of the food that we grow and raise is wasted. So let's start there. What innovations, if any, are we seeing? Are we seeing a greater recognition of the need to reduce food waste in industry?
The short answer is yes, definitely. It's a very fragmented industry, right? And so there's wastage, all along the value chain. And I guess what I would say is if you have one takeaway from what to talk about today, food waste at home it's an important topic. It absolutely is. There's a lot of food waste that happens in the overall production system that is generally, quote unquote, invisible, if you will. And so there is actually a lot of innovation happening. It ties to that earlier question around food safety, blockchain, identifying, what is actually going to, be in a place where it could spoil and need to be, for regulatory reasons, disposed of. So can you better manage the supply in the first place, such that you're putting the supply out there such that it doesn't need to be wasted. So there's lots of, I think, opportunities there. I think a lot of them really are hidden in the value chain, so to speak. And there are opportunities in restaurants and in homes, but from a value perspective, I think you'll see the upstream respond to that probably first, just because the margins there are very thin to begin with, and there's a limited number of players involved.
It's an interesting aspect of waste, food waste, that people don't think about, which is that a number of food banks receive a substantial amount of items for their customers based on things that have expired the buy best buy date or sell date, but are still perfectly okay to consume. That as food manufacturers and grocery stores become more efficient and have inventories in real time, et cetera, the amount of commodities being donated to food banks is significantly coming down. And that raises the question of, now what? So as we think about food waste, it's an interesting consequence of being more efficient. We have to come up with different strategies for helping those who are struggling in terms of food access.
I think we have time for one more.
Okay.
Good? Because we'll have another session coming up.
Mr. Secretary, Bill Leedy, Waterloo West High, 61. The transmission of electric energy from wind and solar in the Great Plains could be accomplished by hydrogen and pipelines. We need 9 kilograms of water for every kilogram of hydrogen we produce. Therefore, large hydrogen transmission pipelines are water pipelines. Do we need to do the calcs to decide whether we should try to run the country on Great Plains wind and solar moved by hydrogen and transmission pipelines, which are also water pipelines?
That sounds like it would require an infrastructure investment, which we seem in this country to have a hard time getting to. But anyone?
Well, I mean, I think you've hit on a good question. People can do analysis on any advanced idea based on what you know how to do now. What we're talking about, or what I talk about mostly, is what can we possibly do? So your 9 to 1 is basically worst case right now. The potential to do water electrolysis of seawater, so an impaired water source, exists, as long as you can protect the catalyst from the ions in the system that will contaminate it. That's what we as material scientists work on. How fast can we make progress? I don't know, but we try to do it as fast as we can, because then we get a bigger paycheck.
Well, I want to thank the panel for an informative conversation. I just want to make one comment in closing, and it has to do with the government regulation that was mentioned earlier. This is probably no secret to the people in this room, but the reality is governments are not really structured to make the kinds of decisions that need to be made relatively quickly in order to get technology into the marketplace. And there needs to be a real conversation in this country about how we create a regulatory system that matches the speed of change, because today that is just not the case. And our economy and our way of life is, I think, challenged by that. There are others in the world that have more authoritative decision-making that allows them to get decisions made more quickly and investments made more quickly, which could allow them an opportunity for advantage on all of these technologies. So it's something to think about in terms of policy and formulation and strategy. It's not just the science, it's getting the science into the marketplace. And once it's in the marketplace, making sure that consumers have enough information, there's enough transparency, so that there is great acceptance in the marketplace. Otherwise, that too can create problems. So please join me in thanking the panel for interesting conversation this afternoon.